Hey Math 1, got another video for you, lesson 1.3. It's really just an extension of 1.2, so I think we can just dig in right away. It says determine the comparison sequence of the given numbers, and then in parentheses I put the example is 3 is less than 4 is less than 5. And I ask you to show proof. So bottom line, at the bottom of this page, it basically is asking you to say, what's the order in which these numbers should be arranged and what inequality symbol should go between them? So before we try to figure that out, let's just figure out how the numbers can be written in the same language as one another. So when we see root 15, all right, root 15 is like the king here. We know it's 3 point something that's really close to 4, but we also know that 3.7 is something that's really close to 4, right? And 35 over 9. If we figure out sort of like an estimate of what that is, it's 9, 18, 27, almost 36. It's 3 and 8 ninths. So what we're dealing with here are three numbers that are probably really close together. So we need to have precision. We need them to all three of them be in the same language. So let's convert them all into square roots. All right? And you know how to do that. All you got to do is multiply the number times itself, and that converts it into a square root. So we're going to do 3.87 times 3.87. And 35 over 9 times 35 over 9. I'm going to ask you guys to pause the video right now, try it on your own, and then come back to me. All right, you guys have tried it on your own. Let's see what you came up with. So this is 49, carry a 4, 56 plus 4 is 60, carry a 6, 21 plus 6 is 27. So that should be your first row of calculations. All right, now we're kind of like eliminating that 7 as a placeholder, which means we're really talking about 80. 8 times 7 is 56, carry the 5, 64 plus 5 is 69, carry the 6, 24 plus 6 is 30. All right, that should be your second row of calculation. Now again, I'm ignoring both the 8 and the 7 on the bottom, which means we've got two digits that we're ignoring, but we're just assuming they're zeros. So I'm taking 3 times 7 is 21, carry the 2, 3 times 8 is 24, plus 2 is 26, carry a 2, 3 times 9 is 11, 3 times 3 is 9, plus 2 is 11. And that should be your third row. At this point, you should add the columns. And then you are 1, 2, 3, 4 digits right of the decimal point, which means you're going to have 4 digits right of the decimal point in your calculation. So, if you got 14.9769, congratulations, you've got the right number. Nice work. And you know that it's less than root 15. Awesome. And really what you should do is you should say, this means that 3.87 is exactly equal to the square root of 14.9769. All right, do the same thing with 35 over 9 times itself. Remember, it should be the bottom times the bottom and the top times the top. All right, so you got 81 on the bottom. 35 times 35 should be 1,225. And yeah, we need to figure out if 1,225 is somewhere in this minuscule region between 14.9769 and 15, or if it's in fact above 15, or maybe below 14.9 ... So this is where we would go off to the side and say, how many times does 81 go into 1,225? Well, it's a pretty safe bet to say that it's at least 10. And that makes sense. So multiply by 81. So 1 times 81 is 81 under the 122. dropping a 5. 81 goes into 415. Think about 80 going into 400 5 times. 40. All right, we know it's bigger than this one. It's 15 point something. And we know it's bigger than this one because there's still a something afterwards. See? There's the subtraction is 10. Bingo, 81 goes into 100 one time. Don't need to figure out anything else. All right? 35. All right, so what all this means is that 35, here I'll put it all the way over here so it's not all cluttered up, is approximately, that means it's not exact because I stopped at that digit when I was dividing, the square root of 15.1 with a bunch of stuff afterwards. All right, so this tells us all we need to know. So which one's the smallest? Root 14.9769. But we're comparing the original numbers. So you're going to say the smallest number, we'll say this space is for our comparison sequence. The smallest number is 3.87. It is less than the next smallest number, root 15. Because when you compare root 15 to root 15.1, the 15.1's just got a little bit more. And then the largest one of them all is going to be originally 35 over 9. And there's your final comparison sequence. So just to be clear on this, it's not the final product that I'm putting the most importance on. It's, can you prove that this is what's happening? Can you prove that this is what's happening? If you just give me bare minimum calculation, I'm going to assume you use the calculator and you're not going to get accepted work for that. So just make sure that you're putting in the proof that is necessary to back up that comparison sequence. Okay? We'll do one more example. All right, I threw something different at you. We've got negative numbers. So, this one is negative 4 2/3. This one's negative 4.66. And this is negative root 22. Now again, if we did just a quick estimation of what's going on here, root 25 would be, well, I guess we're talking negatives, right? So negative root 25 would be negative 5. Negative root 16 would be negative 4. So it's negative 4 point something. Well, great. We already know it's negative 4 point something. And it seems like it's a little closer to 5 than it is to 4. As are these two decimals. These two decimals are actually pretty close together as well. Maybe you guys remember that 2 divided by 3 was 0.6 repeating. So it's negative 4.66, 6666666, with an infinite number of 6's afterwards. So sometimes it's hard to know where to start here. A lot of times students are really comfortable with just the decimals. So recognize this. Don't worry about the decimal to start with. When you're making that calculation, just take 4.66 times itself. Pause the video, try it on your own. All right, let's see if you come up with this. So it's 36, carry the 3, 39, carry the 3, 24, 27. Drop a 0, 36, carry the 3, 39, carry the 3. Oh, look, it's the same thing. 27. Again, you're comparing your rows of calculations as I'm moving forward. 2 zeros. 4 times 6 is 24. Carry the 2. 4 times 6 is 24. Carry the 2. 4 times 4 is 16. Plus 2 is 18. So go ahead and add them up. I think that's 21. 13, yeah. 21, you're carrying a 2 there. 4, 10, 17, 1. All right, so it's 21.7156. Okay. Hey, that's interesting. You know why? Oh, wait. Darn it. I thought we could make a decision. We could say like, hey, this number has to be a larger digit than that number. But see, this is still larger, so we have to test 4 2/3. You got to multiply it by itself. So I'm going to change 4 2/3 into a mixed number to a fraction. So 4 times 3 is 12, plus 2 is 14. So it's 14/3. Oh, we're gonna get off easy with this one. Because 14 over 3 times 14 over 3, these are two perfect squares that are commonly memorized to math students. 9 on the bottom, 196 on the top. I'm not saying you have to have 196 from 14 squared memorized, but it's a nice thing to have in your back pocket. So it's 196 over 9. The question is it bigger than 22 or is it less than 22? So we're going to do that manual division. 9 times 2 is 18. 9 goes into 16. Oh, so close, but not quite. Let's just make sure it's above 0.7. Because if it's not, then that means I might have done something wrong over here. Okay, drop a 0. Oh, wait, my bad. This should be 1 times 9 is 9 here. Oh my goodness. Get out of here. Oh no, am I running out of time? Okay, I got 3 minutes. 196 divided by 9 is 2. 1. Drop a 0. 9 goes into 70 7 times. Ooh! Oh, but it's 0.7 repeating. Okay, it's just bigger. Which I guess we should have thought of that right away. This is only 6 thousandths bigger than 0.66, and it only went up to 21.7. We should have figured out that it's not going to have enough oomph to get up to 22. At any rate, it's not a bad idea to test these things out. So, now you ask yourself, we've got negative 4.66 is equal to the square root of that. And we have negative 4 2/3 equals the square root, and I guess that's a negative, of 21, and this is actually 7/9. Remember last video? 0.7 repeating, 7 divided by 9. But it would maybe be a better thing to put the decimal because we're comparing it to a decimal. And then you got negative root 22. So which of these is the smallest? Well, you got to think about negative numbers now differently. 3 is less than 4, which is less than 5. Most people can agree on that. But negative 5 is less than negative 4, which is less than negative 3. The reverse, it switches, right? Those who are first shall be last, and vice versa when you talk about making negative statements with that. So, who is the smallest number? Negative root 22 now is the smallest number. So my number comparison sequence should be negative root 22 is the smallest number, so it's less than. This one's going to be the middle one. And I'm using the original value, negative 4 2/3, okay? And it's less than the digit that has the most value, which is negative 4.66. Okay. Good luck.